Hello students, welcome back to our channel Diksha Karnataka. So your COMEDK 2024 exam is approaching and we have started a series where we are discussing the top 30 questions from all the important chapters. So in today's video, we'll be discussing the top 30 questions from the organic chapter, that is Haloalkanes and Haloarenes. Okay, so you can easily expect like 3 to 4 questions from this chapter. It is a high weightage topic and an easy and scoring topic. So if you are able to solve these questions, you can assure yourself that this chapter is ready for your COMEDK 2024 examination. Okay, so now let us start with the first question. The first question is, in the elimination of bromine from 2-bromobutane results in the formation of. So you can see if we have 2-bromobutane, okay. Now we have one H here and we have one H here. So I'll mark it as H1 and H2. So you can see there is a possibility that these two can eliminate, and there is also a possibility that these two will eliminate, right? Now if the first one H1 eliminates, then we will get a product like this, and if H2 eliminates, then we will get a product like this, right? So according to Seidzeff rule, the more substituted alkene is always formed. So the product here will be the predominantly 2-butene, right? So correct answer for this question will be option number B. Okay. Next, in the given reaction Zn and ether. So this reaction is very similar to your Wood's reaction. So what happens here? We have chlorine and here we have chlorine. Here we have CH3. So this chlorine goes and we get a radical here, close, and we get a radical here, and then this one joins. So the product we will be getting here will be this one. Okay. So the correct answer for this question is option number A. So let us see the next question here. An alkyl chloride produces a single alkene. This is very important. On reaction with sodium ethoxide and ethanol, the alkene further undergoes hydrogenation to yield 2-methyl butane. Identify the alkyl chloride from amongst the following. Now, whenever you get a single alkene as a product, you must identify that the halogen group will be in the terminal carbon. Okay, it should be at any end carbon. So now from that you can see this option number D we can eliminate, because here the chlorine is present in between one carbon. So now we will see the next one. The hydrogenation will give you 2-methyl butane. So if I have this one, this is 2-methyl butane. Okay. Now I can draw hydrogenation means there should be a double bond, alkyl halide. So we can draw easily, get this one. So you can see here methyl, and here if I have chlorine and this is my H. Now when you treat it with NaOT, sodium ethoxide with ethanol, then what will happen? HNCl will go out. So we will get this one, right? Now when you do hydrogenation, we will get CH3, then CH3, CH, CH2, CH3. Okay. So now if you see here, the correct answer we can get is Cl, CH2, okay, and then this is we have to find the alkyl chloride, right? So CH2, Cl, then CH, CH3, CH2, CH3. So correct answer for this question will be option number C. Next one, isopropyl chloride undergoes hydrolysis by. So we know tertiary generally prefers for SN1, primary prefers SN2, and the secondary can be with both SN1 and SN2 based on other factors. So here, since isopropyl chloride is a secondary chloride, so it can undergo both by SN1 and SN2 mechanism. So correct answer is option number C. Okay, next question. So we have this one with bromine, and you have CHBr, CH2Br. So when you treat alcoholic KOH, there will be one elimination of HBr and NaNH2 another elimination. So first we will get here is one ethane group attached to the benzene ring, right? Now when you treat it with again NaNH2 and CH3, so what will NaNH2 do? So it will abstract one of this terminal hydrogen, which is highly acidic. So we will get this compound like this. Oh, sorry, C triple bond CH will get. Okay, and then here this is now a nucleophile which can attack on this alkyl chloride, CH2, CH3. So this one can attack here, this one can attack here, and the chlorine can go away. So the product we will be getting is this one. We will get a benzene ring, okay, and then we have triple bond, and here this alkyl group is attached. Right. So the correct answer for this question will be your option number B. Okay. So you can see first there is an ethyl benzene or alkyne group is attached to the benzene ring. Then this hydrogen will be removed, and then it will behave as a nucleophile and it will attack on this one. Substitution reaction will take place. Next question, let us see. Which of the following is an example of SN2 reaction? So, you know, primary halides will give you SN2 reaction. So, the first one is a direct substitution. So, this is an example of SN2. That is correct option is option number A. Next, the major product in the following reaction is. So, if we have this one, 1, 2 and then chlorine and bromine, right? Now, when you do Na ether, so what will happen? This one will go and this one will go, and this two will join. So 1, 2, 3, 4, 5 membered ring we will get, and we will have one CH3 group. Now the next one is Br2H nu, right? So if you see, this will replace one hydrogen and it will replace the hydrogen with bromine. So we are having so many hydrogens. So if you see, this is the tertiary one, most stable one. So here the hydrogen will be replaced with the bromine group. Okay. So for example, if I write this is A and then this is B and we have to find. So this will be my first A. This one is A. Okay. Then this is B. Now from here what is happening? From here you are having with, you are given with C2H5O minus, right? So this can abstract this hydrogen. This one will come here and bromine will go out and we will get a substituted double bond, that is CH3. So here now there is possibility in this one also, that is same thing. So the correct answer for this question will be option number B. Okay. Now next one, which of the following is not true for SN1 reaction? So you know SN1s are favored by polar solvent, that is correct, because here carbocation intermediate is formed, so that will be favored by polar solvent. Tertiary alkyl halides generally react through SN reaction, this is also correct. Now the rate of the reaction does not depend on the molar concentration of the nucleophile. Yes, it only depends on the concentration of the Rx or the alkyl halide. Now the primary alkyl halides generally react through SN reaction. This is wrong statement. So correct answer will be option number D. So SN1, if you remember, order is 3 degree, 2 degree and 1 degree. And for SN2, the order is 1 degree, 2 degree and 3 degree. Next, arrange the given compounds in the decreasing order of boiling point. So boiling point depends on two things. Boiling point is directly proportional to mass, okay, and indirectly, or we can say inversely proportional to branching, right? Now if you see here, all the three compounds are having your 4 carbons, but we have to decide on the basis of branching. So first one is having no branching, so it will have the highest boiling point. Then comes 3 and then comes 2, because here there is more branching. So 1, 3 and 2 is the correct answer. Option will be option number A. Next, gamexine is the name of, so it is the benzene hexachloride, that is option number C. A compound that undergoes bromination easily is. So see, bromination when we do, that is a electrophilic substitution reaction, right? So the ring on the benzene, or the benzene ring should be, to accept this one, it should be more nucleophilic. Okay, so if it is highly nucleophilic, it can react easily with the electrophile. Now to make it nucleophilic, we need an electron donating group, which can activate the ring or can increase the electron density on the ring. So if you see, toluene can increase the electron donating group, it has plus I effect. Benzoic acid will minus R effect, it will reduce, so this one cannot be the answer. Phenol has OH, which has plus R effect, and benzene is neutral. So you see, phenol, in this case the ring will be highly activated, the electron density in the ring will be highly activated and it will react faster with the bromination. So the correct answer for this question will be option number C, that is phenol. Now coming to the next question, which of the following compounds is responsible for depletion of ozone? So we know that all the chlorofluorocarbons or freon is an example of that. So correct answer is option number A. Next, in the reaction CH3CH2IKOH, CH3CH2OH plus Ki is classified as. So you know here this is behaving as a nucleophile, it is replacing this one and I is coming out. So this is your substitution reaction. So we can eliminate first addition reaction. Addition reaction takes place in unsaturated compounds. Okay. Now in this also, what is this one? This is OH minus, it is a nucleophile. So your nucleophile is substituting. So the correct answer for this question will be nucleophilic substitution, that is option number B. Okay, next for SN1 reaction, the order of reactivity of haloalkane, so we know it is 3 degree, 2 degree and 1 degree, so tertiary, secondary and primary. Correct answer is option number C. Now next question, the major product obtained when chlorobenzene is nitrated with. So if we have chlorobenzene, okay, and then you do nitration in presence of concentrated HNO3 and concentrated H2SO4, right? So in that case what happens, so it is a ortho-para directing group, right? Although it is a electron, it has minus I effect, but it has lone pair, so it is a ortho-para directing group. So para-nitrobenzene will be the major product. We will get chlorine here and nitro here, so we will have 4 nitro 1 chlorobenzene, that is option number A. Okay, next question, given what is the relation between 1 and 2. So you can see this is very simple one. Here bromine is present in this position, here bromine is present in this position, and CH3 and hydrogen, right? So how it is obtained? Just by rotating the molecule, okay, just by rotating the bond around the axis. So such type of what you can say, compounds formed which are obtained on rotating are called as your conformers, right? So the correct answer for this question will be a pair of conformers, that is option number B. Okay. Now let us see the next question. We have an organic compound is optically active if. So if it is planar, there is no relation. Superimposable on its mirror images, contain chiral centers. This can be a condition, but not an it is like not a necessary, like even though we have a chiral center, sometimes the molecule may not be also optically active. So the examples are your meso compounds, right? So it should have non-superimposable mirror images, that is the correct definition. So correct answer is option number D. Next, when HCl gas is treated through propene in presence of benzyl peroxide. So we have propene here, okay, and you are treating HCl with benzyl peroxide. Okay, so sorry, we have benzoyl peroxide here. So now what you can do is, you might be thinking that there is a peroxide, right? So we will have anti-Markovnikov's rule. But you should remember that anti-Markovnikov's rule is affected or is applicable only in case of HBr. Okay, all others will react under Markovnikov's rule. So if I add HCl, so this is the, according to Markovnikov's rule, the negative part will go to the carbon having less number of hydrogen. So here this is the negative part. This carbon is having 2 hydrogen, this carbon is having 1 hydrogen. So negative part will come to the carbon having more number of hydrogens. Negative part will go to the carbon having less number of hydrogens. So we will get here CH, Cl, CH3 and then H. Okay. So now what is the product, this one? This is 2-chloropropane. So correct answer is option number A. Okay. Now if this one would have been HBr, okay, then in the presence of peroxide we will get 1-bromopropane. Okay, but HCl and all other do not give this reaction, only it is applicable for peroxides with HBr. Okay, next, the toluene reacts with chlorine in the presence of light to give. So we have here toluene and it reacts with chlorine in presence of H nu. So here what will happen, the alkyl part will undergo substitution and we will get CH2Cl. Okay, the chlorine will not be added to the ring. For that we need Lewis acid, okay, like Cl2 in presence of FeCl3, FeBr3, that will add chlorine to the ring. Here when you take H nu, the aliphatic part will react and this one is called as benzyl chloride. So correct option is option number A. Now next question, in the chlorination of benzene, in the presence of halogen carrier, the reactive species is. So when you have chlorination of benzene, okay, for example, you take this one Cl2 in presence of AlCl3. Okay, so what happens? This AlCl3 Lewis acid accepts a chlorine and we get like AlCl4 minus. So the one which gets attacked or the reactive species is your, or the electrophile produced is Cl plus. So the correct answer for this question will be option number A. Next, the conversion of Cl, CH, CH, Cl to, okay, so we have this reaction CH and then Cl and it is treated and the product is Cl2, CH, CH, Cl2. So what is happening here? The chlorines are added to each bond. So that is Cl2 in presence of CCl4. It forms the addition of halogens. So correct answer is option number A. Okay. Next, in the dichlorination reaction of propane. So this is a good question. Propane is there. In the dichlorination of propane, mixture of products are obtained. How many isomers does the molecule contain? So if you see, we have propane. Okay. So this one will get. Okay. Now in the dichlorination of propane, what products we can form? First of all, we can get like one chlorine is replaced here and another chlorine is replaced here. So the product we will get here is CH3, okay, then CH2, and we have CCl. Okay, this is one product formed. Next one, what you can get is one chlorine is replaced here and another chlorine is replaced here. So we'll get CHHH. Okay, here one chlorine and here one chlorine. Okay, and this one is H, this one is H, this one is H. Now if you see here, this, so the question you have to include the stereoisomers also. Now if you see, this carbon is a chiral carbon here, so it will have its enantiomer. So this is 1, this is 2, and the enantiomer of this one is third one. Yeah, that is your enantiomer of 2. Now one more product what we can get is both the chlorines are replaced from the second carbon. So that is your fourth product. We'll get CH3, okay, CCl, Cl, and then we have CH3, right? So the total number of isomers possible will be 4. Correct answer is option number C. Okay, so once again you can check. First one we did, both the hydrogens are from the first carbon. Second one we did is both the hydrogen, like one from first carbon and one from second carbon. In that we got the second carbon is optically active, so its enantiomer will be there. And the fourth one is both the hydrogens of second carbon are replaced. Okay. Now if you replace this one, here it is again the first, it is similar to the first product. Okay. Now let us see the next question, which has the highest melting point. So high melting point depends on the symmetry. So once the para dichlorobenzene is there, it is packed effectively due to its symmetry. So the tightly packed means more energy will be required or more temperature is required to break them. So the correct answer for this question is option number D. Next, in Friedel-Crafts synthesis of toluene, the reaction in addition to AlCl3 is. The reactants in addition to AlCl3 is. So if I want to do Friedel-Crafts synthesis to toluene, to produce toluene, we need benzene and we need CH3Cl in presence of AlCl3. So AlCl3 is already given to us. So what are the extra that we need? Benzene and CH3Cl. So correct answer is option number B. Next question, the conversion of 2,3-dibromobutane to butene with zinc and alcohol is. Okay, so if you see here, we have 2,3-dibromobutane. Okay, so we have H here. 2-but2-ene. So this is converted to but2-ene, right? So we'll get C but2-ene. Okay, so now if you see here, so first of all, this is alpha carbon, right? So you'll have your beta hydrogen here. So HBr is removed from here and HBr is removed here. So that is your beta elimination. Now in presence of Z, so what happens here? Zn gets converted to ZnBr2. Now if you see, oxidation state of Zn has changed from 0 to +2, right? And so that is what, this is getting oxidized and this one is getting reduced, right? So it is also a redox reaction and there is also beta elimination. So the correct answer for this question will be option number D, right? Okay, next one. SN1 reaction of alkyl halides leads to. So there is a carbocation formed in the intermediate, right? So after that, the carbocation intermediate is a planar molecule. So a nucleophile can attack from the top and can also attack from the bottom. So we will get a mixture of products, that is your racemization. So correct answer is option number B. Now next, the set of compounds in which the reactivity of halogen atom is in decreasing order is. So first of all, we have chloroethane. Next we have chlorobenzene. Okay, and then we have vinyl chloride. Okay, so now if you see here, the chlorine is attached to the sp3 carbon, right? So here, that is why this bond can easily break, and this one will be highly reactive. Now here what happens, this carbon, it is like the bond between this one, okay, it is a partial double bond character, not a pure double bond, but it is a partial double bond character. So breaking here will be easier than this but difficult than this. Okay, now if you see this one, this is the carbon which is attached to a pure double bond, so sp2 hybridized carbon. So that is why the order will be chloroethane, then chlorobenzene, and then vinyl chloride. So correct answer is option number D. Okay. Now next question, which is the correct order of decreasing order of dipole moment? Again, this is one important question. You have CH3Cl, you have CH3F, and you have CH3Br. Okay. Now you see dipole moment depends on two things, electronegativity and size, right? So that is your distance. So if you see, fluorine is the highest electronegative, but distance will be small in this case. Chlorine is medium electronegative and bromine is the least electronegative, but the distance will be more in this case, right? So comparing these two factors like Q and R, you know, dipole moment is equal to Q into R vector product, right? So now if you see charge, in that case fluorine will be highest, but in distance R will be lowest. In bromine, this Q value will be least, but R value will be more. In chlorine, both will be half, like in between the values. So that is why what it is found that the correct order of dipole moment is first is CH3Cl, then CH3F, and then CH3Br. So this result has come due to the combined effect of the charge and the distance. So the correct answer for this question will be option number B. Okay. Now next question, among the following, the most reactive towards SN2 reaction is. So for SN1 reaction is, so we need to understand the stability of carbocation. Wherever the carbocation is more stable, there the reaction will be faster. So now if you see here, it is CH3, and then we have CH, and then we have Br, right? So once this Br goes, we'll get a tertiary carbocation here, which is a stable one. Now if you consider option number B, okay, so in option number B you have C6H5, and then you have CH2 plus, right? Then Br will go, we'll get a plus, but this is a benzyl carbocation stabilized by resonance. Now if you see third one, okay, we have again CH3, okay, CH3, CH2, and then we have here one. So now if you see, this carbocation is a primary one, right? So this is the least stable, this is also primary one. Now out of these two, if you consider tertiary and benzyl carbocations are more stable due to stabilization by resonance. So the correct answer for this question will be option number B. Okay. Now next question, when the concentration of alkyl halide is tripled and the concentration of OH minus is reduced to half, the rate of SN2 reaction increases by. Okay, this is also one important question. In SN2 reaction, the rate depends on the alkyl halides as well as on the nucleophile. But in SN1 reaction, it depends only on the concentration of alkyl halide. So if I write the rate here, it will be equal to concentration of alkyl halide, okay, and concentration of the OH minus or the nucleophile. Now according to the question, it has become the concentration of alkyl halide is tripled. So we can write 3 times of Rx, and the concentration of OH minus is reduced to half. So OH minus, that is half. So we can have we can write the new rate like 3/2 K into Rx and then OH minus ions, right? So now if you see this value, it will come around 1.5, right? So the rate of the reaction increases by 1.5 times when the concentration of Rx is tripled and OH minus is reduced to half. So the correct answer for this question will be option number C. Okay. So these were the top 30 questions from the chapter Haloalkanes and Haloarenes. So please solve them and revise the concepts. If you have found this video helpful, please like, share and subscribe our channel. Thank you.